Okay, I want to speak briefly about what we're calling PA support initiatives. Last fall, the CBP was entering essentially its second year of funded existence, and we decided at that time to start the process of transferring CBP technology to active PAs in the complex. So what we started doing at that time is looking for openings in the PA schedule. That is, we're looking for PAs that are either in preparation, the original document, or else being revised as part of a review cycle. Looking for issues pertaining to cementitious materials, obviously. And then opportunities to bring CBP expertise to bear on an issue to reduce uncertainty in the PA. With kind of marginal additional effort to our already planned CBP activities. And then the second prong of the approach was to collaborate with the PA owner on key inputs and results interpretation to make sure that we're synchronized with the needs of the PA owner. So last fall at our September 2009 team meeting, we recognized the saltstone as the PA, at least at the Savannah River site, that was available for us to provide assistance to. Obviously, you can't support a PA that's sitting on the shelf and not being actively worked at the time. So in September, the PA was in the process of an LFROG review, and a revision C was about to be issued within a month and submitted to the NRC for their review. So that we figured that provided us roughly a 6 to 9 month window that we used to provide some supplemental analyses to the PA to bolster that the Rev 0 coming out. So the opportunity we focused on was the PA baseline analysis of external sulfate attack. The PA folks had already picked up on the stadium code as a useful tool for predicting the formation of ettringite, the expansive phase associated with external sulfate attack. Now the PA analysis was a single layer analysis, and the transport properties were not assumed to be affected by the advancing ettringite front and any damage that would be occurring behind it. And the damage model in the PA was a very simple one, which was just that if there's ettringite present at a location, then we also assumed that there was physical damage at that same location. That physical damage being cracking, spalling, in whatever form. And then essentially the effective hydraulic properties for the material were gotten by averaging 2 layers, sublayers, a degraded layer, and then the intact layer in front of the ettringite front. Okay, so some of the uncertainties in this analysis are listed here. One, because this was a single layer analysis, there's some uncertainty in what are the conditions that were applied on each side of the concrete that are physically adjoining soil or saltstone material. And then the obvious one was does physical damage really occur? I mean, just because we predict ettringite doesn't automatically imply physical damage. And then the third one was under the unsaturated conditions this material is exposed to, would cracking, if it occurs behind the ettringite front, would that accelerate, hinder, or not affect the rate of sulfate attack by increasing or decreasing the rate of delivery of sulfate or other reactants to the front? So looking at what CBP expertise we could bring to bear to look at these uncertainties, we basically worked on 2 issues. One is we'd realized that as part of what one of our ongoing CBP tasks called Task 7, we had done some 2-layer simulations with stadium on our saltstone reference material using inputs that were refined compared to what was done a year or so earlier with the performance assessment. And then the second thing is we we're starting work on adding damage mechanics to reactive transport model, specifically the leach excess orchestra model, and kind of the specifics of that are described in this paper that's recently published. Okay, so what we learned from the stadium two-layer analysis that we had done with CBP funding, and these were done by Dr. Eric Sampson, who's with us today. We learned a couple things. First of all, that the sulfate at the saltstone concrete interface is lower than is assumed in the PA initially, and it also decreases through time, whereas the PA assumes a constant value. So I think when we're able to write this up and bring these insights to the PA owners, we hope they'll kind of be happy about that outcome, that it looks like there's additional margin there that wasn't realized. As far as the damage mechanics, I'm not going to go through the specifics of that. I'll just mention that there's a nice Waste Management 2010 paper on this by our CBP folks here, the students and faculty at Vanderbilt and ECN. But I'll just mention the key here is to take a basic reactive transport formulation and add to that calculations on stress and strain and what that means as far as damage mechanics. Again, I won't go through this, just to indicate that there's a literature-based damage model that translates the computed strain from the reactive transport calculation into critical stresses that would lead to damage. Now, this is work that's going on right now. I actually found out that these measurements, I think, have just gotten this last week. Vanderbilt is doing some laboratory measurements to initialize the model properly with the right mineralogy and such. And we're expecting the actual results of this analysis to be for the saltstone facility be available probably in summer of 2010. So that's our initial PA support effort. Looking ahead to what we are thinking of doing here in the next 6 months or 12 months, are a couple of things. One is focusing on gas and liquid phase carbonation and oxidation of slag-bearing concrete and saltstone. That's a key to immobilization of technetium and saltstone, for example. And that's work that's already underway with extensions to leach excess and orchestra. And then a second, topic I think we're going to look hard at pursuing is defining the environment around the primary steel liners and liquid waste storage tanks in order to get a much more accurate prediction of corrosion. So the grouts that sandwich the steel have a strong effect on the corrosion rate that's predicted. And that has applications not only to tank closures but also some D&D applications.